Good evening, everybody. Tonight is night 10 of our mini boot camp. So we are getting near the end of this series. Only 2 more lessons left after tonight. So I hope you guys have learned a ton and are ready for a few more lessons of some crazy advanced topics in JavaScript. They're not that bad, hopefully. So for anyone who is just joining us for the first time, let me tell you a little bit about what this web series is, what Lambda School is, and break it all down for you. So my name is Deandra Ryan Moss. I'm an instructor at Lambda School, which is a web development and computer science immersive. So we have a 6-month curriculum, which will get you to the point where you are ready to jump into a job in web development. We have our 6-month full-time curriculum, and then we also offer a year-long course that's part-time. So if you need to work, if you can only take our classes in the evening, that's perfect for you. So throughout our curriculum, you'll learn all about front-end development, HTML, CSS, JavaScript, as well as various front-end frameworks. You'll also learn the back-end. We deal with Node.js, and you'll put that all together with a personal project. We also dive into computer science topics. That's something that sets us apart from a lot of these other immersives, is that we do want to give you those important trade skills, such as how to actually build what you're going to build. But more importantly, we want you to learn some of the computer science basics. So we also do some C and some Python and talk about algorithms. It's just a really great, well-rounded way to get yourself to the point where you are ready to jump in on the job. And one thing that's even more awesome is that if you're not able to pay anything up front, that is totally fine. So we have a de-risked education model, which means that you don't have to pay anything to enroll in our course. Instead of making you pay our tuition up front, we offer a plan where you can either pay back tuition for the first year or first 2 years of working a full-time computer science job. So we don't require you to pay until we've gotten you the job. So in that way, there's no risk of going through our boot camp, shelling out a bunch of money, and then not getting the job that we promised. So that is really awesome. If you're interested in that program, we have a new cohort starting in April. It's coming up soon. It's not too late to apply, but I would get on it if you're interested in that. If you're not quite ready to jump in so quickly, we offer one starting every single month. So talk to our admissions team. We'll get you in there. That is Lambda School's main curriculum, but what you are watching right now is our mini boot camp. So this is kind of a crash course in JavaScript, HTML, CSS. The idea is to get you guys ready for the main curriculum, or if you're just stumbling upon this on YouTube, it'll just help you get a solid foundation in these basic web development topics so that you are ready to pursue whatever you're planning on doing next. So without any more rambling, let's go ahead and jump in on our topics. So last night we did callback functions. So we're getting in the weeds here. Callbacks can be pretty confusing because we're dealing with functions inside of functions being passed around, but they're super critical, super high powered, and without them, you really aren't utilizing the full force of JavaScript. So today we're going to talk about something really related, another important subtlety of functions, which is scope and closure. So let me go ahead and share my screen, and then we can dive on into the fun stuff. Okay, let's start out with a little review of callbacks from last night. So as we know, when we're writing function, we can specify these parameters that come in. So we might have some value, and then we do stuff with the value over here. And that's how functions work, right? We can have some input, manipulate it, possibly do output with a return statement. And we've seen a lot of examples throughout this mini bootcamp of functions that take in strings or numbers or maybe even arrays or objects. But what we saw last night for the first time is that we can also have a function itself as a parameter. So we could, for example, have maybe a number and then a callback function. So that is saying that my function takes in two arguments, first a number and second a function. And then inside the logic, maybe we call the callback and pass in the number. And then perhaps we even return that result. So we're able to use this function just as we've been using all other functions in JavaScript. We're just able to call it inside of the function description. So this is a higher order function, a function that takes in another function as a parameter. And just as a reminder, callback refers to that function that's being passed inside. And we also saw that a really great application of higher order functions is in some of these awesome built-in array methods. So if we have a collection of numbers here, we could do array.forEach, pass in an anonymous function, and then do something simple like console log each item. So this is a great application of higher order functions. We're able to pass this anonymous function into the arrays for each method that allows us to console log every item. It's a really sleek, effective way to iterate through an array without actually having to write a for loop. We also saw that we could use map or reduce, which are a little more complicated but extremely powerful. So hopefully you guys are feeling pretty good about all of that. And we can go ahead and jump into our next topic. So before I get to scope or closure, I want to talk a little bit about an idea called functional programming. So functions work in a really cool way in JavaScript, and JavaScript in general is an extremely flexible language. So with our lessons on classes, we talked about how object-oriented language, we can write in this object-oriented style where we're creating classes and using them. There's another style of programming called functional programming. And once again, JavaScript isn't a true functional language, but we can treat it functionally. So let me tell you a little bit about what functional programming is. While in object-oriented programming, everything is an object, in functional programming, you try to think of everything as being a function. So for example, if I had a function called add numbers, oops, that's not how you declare a function. Add numbers, and then we take in two values and we return out the result. So we've written a function. Now say we wanted to do something even more complicated, like manipulate a group of numbers in some more advanced way. So in a non-functional way, we might just declare start value of 4 and declare start value 2 of 6. And then maybe we go ahead and throw these guys here. So that is totally valid JavaScript, right? And we add them together correctly. But that's not functional because we just have these variables kind of floating off in the ether. And we want everything to be a function. That's one of the tenets of functional programming. Another thing to know is, for example, let's say that we're like, okay, well, we don't want to do that. So let's wrap everything in a function. So we'll call this do more math. Okay. So this is looking a little more functional because we've wrapped everything in a function and we've called add numbers up here. But it's still not quite technically functional because we're calling this function name that exists outside of the function. So really anything we use inside here, we want to pass in. So we could instead say it takes in a callback and then apply the callback over here. So now this is truly a bit of functional code. And the two critical tenets are that there are no kind of random variables floating out in the ether. Everything's inside of a function. And then all the logic that's inside the function is coming from the parameters. Nothing, we're not calling any variable that exists outside of the little curly brackets. Everything we use inside of this do more math, we either declared it within or it came from the argument. So that is, in a very, very quick and dirty nutshell, what functional programming is. And the good news is that you don't have to understand that in detail. That's not really something that we're going to be asking you about on the homework, but it's an important lens to look at this, because throughout this lesson, I want to get to why do we need to use closure? Why do we need to understand scope? And it turns out that this lens of functional programming sheds a lot of light to it. So wanted to introduce you to it, and we'll come back to it throughout the lesson. As with everything else we introduce in here, you don't need to have a deep and thorough understanding. We just want the gears to start to turn. So now that we have a basic idea of what functional programming is, let's talk about why JavaScript is a great language to functionally program in. And that's that functions work in this really cool way. They're very flexible. We can treat them like almost any other variable. For example, we can declare them just like a variable. So I've created my function. All it does is it console logs some number plus 1. So we can go ahead and run it, see that it works. Awesome. And notice that I've used the variable, the anonymous function declaration style. So I've just created a constant, called my function, and then set it equal to an anonymous function. From your perspective right now, that probably just seems like an arbitrary syntactical difference than, for example, this declaration style. But there is something more subtle going on, which is this idea that not only can we create functions, we can also pass them into different variables. And that's not the case in a lot of programming languages. So for example, having declared my function in this style, we can still create another variable and just go ahead and save that in there. So in the same way that we can pass around numbers or strings and save them into declare new variables and save them there, we can do the exact same thing with functions. So my function, of course, works, but we can also now run other function. And it does the same thing. So that's something really cool. Another really cool piece about functions in JavaScript is the fact that it's even possible to do a callback. Isn't it awesome that we can actually just pass around functions like any other variables? Once again, this is something that you shouldn't take for granted, because it's not a tenet of every single programming language out there. This is not allowed in a lot of languages. And for those of you coming from especially more traditional object-oriented languages, that might have seemed like blasphemy when I introduced it last night. I know I started in Java, actually. And when I first learned this, I was like, no way, that can't be allowed. So functions are super flexible. They basically work like any other variable. We can pass them around. We can save them into variables. We can make copies of them into variables. And there's one more really cool thing we can do with them, which we haven't seen yet, and that's that we can return them. So we've seen that a callback function is where we have a parameter that's a function, but we can actually have a return value that's a function. So there are a couple different ways we could do this. So let me change this around. So let's say that we wanted to create some inner function. Let me rename this actually outer function. So let's say we have an inner function that we want to create inside of here. And then maybe inside of this thing, we run the callback on X, and we return that. We can return our inner function. So let's break down what's actually going on here, because it's pretty meta. So we have an outer function. We have two parameters. And then inside of the function logic, we declare another function. And this function doesn't have any arguments, but it returns a value that we've calculated using the arguments of the outer function. So we've declared this function, and then we go ahead and return it. So that means that if I go ahead and call outer function, and let's say my x is 5, and my callback is just console.log, what is this result going to be? Well, this result is going to be a function because we're returning this variable, and this variable is a function. So if I call result, let me clarify that a little, result function. And I notice that inner function doesn't take in any arguments, so I can just go ahead and call it. Whoa, that's crazy. So I called outer function, I gave it some parameters, and then out came a resulting function, which doesn't take any arguments, but somehow it utilizes these up here. So it's almost like we're preloading result function with this information, and then we can call it at will, and these arguments up here have been kind of secretly stored within the result function. So on a surface level, we've just experienced both closure and scope. Those are both two critical concepts to understand what in the world just went on here. So as a user, what we'll see is calling some sort of initial function with some arguments that loads into a result function that then can somehow use those original arguments. So let's not get too hung up on that. I'm going to break this down with a lot more examples and a lot more detail, and I think it's going to start to make some sense. And this is extremely powerful and extremely cool. So keep in mind, as your brain hurts, that it's growing pains. You are on your way to becoming a sophisticated JavaScript programmer by understanding these concepts like callbacks and scope and closure. Okay, so let's go ahead and look at a couple more examples where we return functions. So let me start with this. Imagine that I have a function called add2, and it just takes in a number and returns that number plus 2. And then maybe I also want add4. X plus 4, and I might need to add 10, right? Sometimes in life you just have to add 10. So as I've tried to grill into you guys, this should be a red flag here because I've just written a bunch of lines of code and it seems like I'm doing the same thing over and over again. We always want our code to be dry. That means don't repeat yourself. So when you find yourself doing something like this, you should pause for a minute and say, hey, there's got to be a better way. Well, one solution, of course, is to just declare a function called add, right? It takes in 2 values. It returns x plus y. Now, if we want to add 2, we can just have one of our parameters be 2. If we want to add 4, we'll just plug in a 4 and something else, etc. So that would work. That's not a bad solution. But what if we really did want an add2 function that behaved in this way, and an add4 function, and an add10? For some reason, we need our code to be in this format where we're just taking in one value and then returning the result. In that case, this add solution doesn't really help us. So we need something more sophisticated. How about this? Y. So instead, we're going to create a meta function called createAdder. And this function is going to generate functions of this form. So like we just saw, this is a function that returns a function. We want the return value to look like this add2, add4, etc. So this y up here is going to be the amount that each adder increments by. And then down here, we're going to have a return function that looks like these guys. So return x plus y. Now, this is similar to that basic add function that I just had, right, where we have an x and a y, we're adding them up. But instead of just having one function that creates, we have this generator function that creates another type of function. So let's see how this works. So instead of declaring these explicitly like we did, let's try this. 2 equals create adder 2. So if I go ahead and console log add 2 function that I've just created, I sure enough see that I have generated a function. So that's good. Create adder is returning a function as we would expect. So let's make sure add 2 works. I'll go ahead and plug in 10. Throw in a few more values, maybe a negative. Well, it looks like add 2 is adding 2. And what's great is now we can create add 4. We can create add 10. And if we wanted 1,000 more of these, we could just generate them with this create adder function. So let's make sure that all these work. 4, 13, add 10. Oop. There we go. So that is great. We've just created this engine called create adder that lets us generate functions really rapidly. This is a process called currying. It's very common in functional programming. If you have studied functional programming, you've undoubtedly heard currying. So like currying favor or making, Indian curry. Curry, yes. Curry is good, both the food and the programming technique. Would recommend both of them, arguably even at the same time. Anyways, so yeah, this is called currying, when we create a function that's designed to create more copies of similar functions like add 2, add 4, add 10. And now that we've seen this awesome curry example, we can talk about scope. So scope is basically, scope is the fact that, look at this, we can use this variable y that came in through our first function in our second one. So this is this idea that we just talked about, that this value that goes into the create adder, it somehow lives inside of this add 2 function. It can tap into the knowledge that this 2 came in at some earlier date when we actually run this. So even though x is never explicitly defined anywhere in this return function, y is never explicitly defined in this return function, it still somehow knows what this y was. And we've called it 3 different times here with 3 different y values, but in add 2, it knows that y was set to 2. In add 4, it knows that the y value is 4, and so forth. And so, this is an idea of closure, and it's made possible by something called scope. So before I get any more into what closure is, let's make sure we understand function scope. So scope looks like this. Let's say that at the top here, I have a variable called number. Very exciting variable name. So if I wanted to, instead of using this currying technique, let's say we want to do something similar. And instead of, explicitly throwing the y value in or currying, as we saw down here, we could do something like this: return x plus number. And it turns out that this works. This is a legal move in JavaScript. If we run add number, it's going to use this variable that exists outside of the function. So this number would exist outside of the scope of the function, which means it's basically outside of these curly brackets, but it's still accessible. So whatever we write inside of a function can reach outside of it and pull values. It's not functional, though. If you're trying to write in a functional style, this is a no-no. We don't, even though we can reach outside, we don't want to. And even if we're not explicitly programming functionally, it's still not always a good idea, because this could be floating out somewhere else. It could get manipulated. we really want to keep everything inside of these curly brackets, because then we know for sure that this add number isn't going to be unexpectedly tweaked by some other goings on in the code. So while this is allowed, it's not the greatest practice. But let's look at the other way. So let's say that I instead declare number within my function. Still works. But what if down here I wanted to console log this variable called number? We get an error. And the reason is that this scope only goes one way. So while if we're inside of the scope of the function, we can still reach out to grab values. But if we've declared something inside of the scope of the function, it doesn't exist outside of these curly brackets. So basically, once the curly brackets are over, it's like this variable never even existed. We, of course, can still have the return value. So the logic, we do have a way of spitting stuff out of functions, return values, and that's why return values are so important, is that the logic that comes before them essentially disappears when we're done. And that's actually, it's nice, right? Because, you know, what if I wanted to use this variable number in a bunch of other places? That would be really annoying if I had to keep coming up with new variable names, especially since the const keyword means we can't redefine things. But instead, this is a constant as long as we're in the function scope. But once we're out, doesn't matter anymore. And let me even demonstrate this really explicitly. So let's say I declared a number variable up here called, and we'll set that one to 10. So if I console log number out here, of course, it's going to look at this one because it doesn't care what happened inside the function scope. But instead, if I move my console log in here and call add number, notice that it console logged the 5 instead. So that is really cool. It doesn't, even though it could potentially reach outside of the function, because we've redefined it inside of the function scope, it's going to prioritize this one. So that is, it's really neat. It can be a little confusing because you could be like, okay, wait, which variables am I allowed to use where? But just remember that as long as we're inside the function scope, whatever is in here goes. This is the first priority, is all the logic inside of here. But we're still allowed to reach out. Once we're out of the function scope, once we're back kind of in this global land here, we have no memory of what happened inside of the function. It's like a crazy night in Vegas inside of this function. Once we're out, we never speak of it again. So that is the idea of scope. And let me just go ahead and show you one other thing, one other area where you've seen scope before, even if you didn't know quite what it was. So remember that there are these mysterious keywords like arguments or this. And when we're inside a function, we can use them. But out here, arguments, it's still lighting up because Replit isn't subtle. But out here, we don't know what in the world these are. So these are keywords that only exist within the scope of the function. If we use these in a function, they become meaningful. But if we try and use them outside of the scope of the function, JavaScript doesn't know what the heck we're talking about. So there's a nice little example of scope that you have seen so far in some previous videos. So let's bring this all back to this idea of querying and returning a function. So what's cool is that this y, which is passed in at the higher level, at this creator level, exists in the scope of this anonymous function. So I am allowed to use y from the outer function inside of this inner function. That is a valid scope move. But as you might imagine, it does not go the other way. So if I try and use this x from my return value function inside of the creator, it's not going to work. It doesn't know what this is. X only exists in the scope of this inner function. So that is scope in a nutshell. And now we are prepared to really dive into this idea of closure, which is super cool, super powerful, and a little confusing at first. So once again, be patient with yourselves. We're dealing with some crazy, mind-boggling topics this week. All right. So closure, as I said earlier, is this idea that this y value, even though technically it only exists inside this creator, can be used down here. So closure is essentially saying that this little function, this anonymous function we create in here, can use anything that exists inside this creator adder. Even though normally once a function's run, things are no longer accessible, we've basically created a hidden copy of it that this little add2 function can grab everything that was inside of creator adder. So let me show you another example of currying so we can dive into this further. So over here, I have a function called getContact. It takes in 2 arguments, a first name and a last name, and it returns this little contact info object. So let me go ahead and create my own contact object with this function. Cool. So it outputs this object over here with my first and last name nicely labeled for me. All right. So say that I am trying to create contact information for everyone in my family. Actually, this is a terrible example because I actually only have one sibling, but I'm going to make up some other fake siblings. So let's say I also have a sister named Elizabeth. All right, so because me and my both fake and real sibling have this really annoying hyphenated last name, this is starting to get a little arduous. I'm starting to repeat myself. I'm just having to plug in this Ryan Moss thing again and again and again. And if I had 12 siblings, it would be really frustrating. I would start to think, hey, this would be nice if I could just plug in the first name and it would somehow know that everyone is going to belong to my family. This is a great opportunity for currying. So instead of this non-currying approach, let's do this. We'll create this kind of meta function. It's going to take in a family name. And then, of course, because we're currying, we know our return value should be a function. And this will just take in a first name. And then I can go ahead and nab that return statement from up there. Oh, all my options are crazy. Okay, so we have this inner anonymous function, which is going to return this contact object. And then we have this outer function, which specifies in advance what is the last name. So once again, this inner function only has one argument, it only has one parameter, this first name. Yet we are able to use the last name variable from up here. So to bring this back to the idea of scope and closure, you would say that the scope of this, that this last name variable is available within the scope of this anonymous function. But this first name variable is not available. It's out of the scope of create family. And if we tried running create family with this variable floating there, we would get a reference error because we're outside of our scope. And then to illustrate the example of closure, we would say that we've created a closure within this anonymous function so that we're able to continue to use this last name variable. So let's show you how this works again. So if I want to create a function called get Ryan Moss, then I could call create family. I could plug in my last name. And then now I can use this to create my own contact info, which is great. But the reason that we love to do this is because if I want to create contacts for all my bajillion siblings, I can continue to do this. Oops. Console.log my brother here. There you go. And if I had 12 more siblings, it would just take 12 more calls to get Ryan Moss in order to create us. So another great example of currying. Cool. So we've seen these two pretty simple examples of how we could use the concepts of closure and scope to simplify our lives. Let me show you an example of where it gets even more complicated. So I'm going to hop back here for a minute to create adder. So what if, instead of, this would be a really impractical way to do things in real life, but it'll illustrate my point nicely. What if instead of just adding our y value, we wanted to add our y value times 2? So sure, we could just go ahead and throw that logic down here, but we could also do this. Oops, that is not right. Okay, so what I've done is up here in the initial function, I've created a new variable called doubled, and I double my y value. And then down here in my anonymous function, I use that variable. And let's make sure that everything is still working. It looks like it. So instead of adding 2, well, that's not a very good name for add 2. So this would become add 4. This would become add 8. This would become add 20. So now if I call add 4, it works as planned. So we saw before that this y is available because we have a closure with this parameter y. It's available down here. But it turns out any variable I create up here, there will still be a closure. This is still available in the scope of this function. So whatever crazy logic I do up here, any variables I create, in a sense, they go away when this function is done being called. But in another sense, there's kind of this ghost preserved copy of them. And that is a closure. Closure is the fact that though these variables appear to go away because the function's done being run, they're still accessible within this anonymous function that we've returned, which is to say we have created a closure. Let me show you one more example of that with our contact info. So what if instead of creating a contact name in this nice, simple, intuitive way, for some reason I wanted to scramble it around. I wanted to actually reverse my last name. So to reverse a string in JavaScript, the simplest way is to create an array first. So we can say last name array. And I'm going to go ahead and call a method called split, which creates an array. And then I am going to create a reverse string. So all I have to do is, there's a nice little reverse method on arrays, and then a nice little join method, which puts it back into a string. So I know I just used 3 methods that you've probably never seen before in rapid succession. You don't need to understand this logic here, though it would be maybe a fun thing to play around with if you're curious. The point here is that I've done some crazy logic in this create family. But because of closures and because of scope, I'm still allowed to use these 2 variables anywhere down here. And the code will remember what they are because a closure is created. So instead of setting this to last name, I can set it to reversed string. And now I've gone ahead and scrambled my last name as expected. And of course, you might want to do even more complex logic if you wanted to fix this capitalization issue. Though it would be especially difficult to deal with the hyphen. I do have to say that after a lifetime of having various forums online reject my last name as invalid, after becoming a programmer, I appreciate the difficulty of dealing with the hyphen a little more. But the point is that, we could do all sorts of logic in here trying to get the capitalizations in the right place, trying to deal with edge cases like names with hyphens or apostrophes in them. And we might write a lot of code actually inside of this create family. So the original example, there wasn't really any logic in create family. We just returned a function. But in real life, a lot of the times when we're querying, there's a lot of cool logic that goes on here. And the key takeaway of Clojure is that if we use any of these variables down in our return function, we create a closure, which means that we're still able to use them later on. So while create family is called, of course, these variables are created, but there's this closure that's created so that reverse string doesn't go away after this function is done being called. We can still call get Ryan Moss as many times as we want, and reverse string is going to be available to us. So that is the idea of scope and closure. And let me just, because I always want to tie this back to why would we do this? Just as a reminder, the reason for all this, the reason that all this is awesome is it basically just saves us time. Though it can be a little bit of a hairy approach to programming, especially if you're new to functions, using this functional scope-oriented technique creates these really sleek functions that saves us tons of time. And it also prevents us from relying too much on outside variables that might change. That is another great thing about Clojure is that, yes, get Ryan Moss can use reverse string, but no one else can touch it. It's essentially baked into this function in a way where no one can augment it. So we don't have to worry about another developer on our team or our future self forgetting why that variable is important and changing it around. It just exists inside of this function. So it's not going to be able to be touched or augmented. So that's great. We like that. We like saving time writing code. We like reducing the possibility of unexpected behavior of functions, and currying, closure, and scope are all great concepts to help us out with that. So I know that things have gotten a little crazy with all these topics that we're introducing. So I wanted to remind you guys that inside of your the GitHub repo for each of these nights, we have a little section with resources. So I did just want to point a few of these out because we're starting to get to the point where you really have to play with this and you really have to take some time with it before you can get a deep understanding. So I did want to bring your attention to Eloquent JavaScript. It's this great book that's free online. It really deep dives into these topics. And chapter 5 is higher order functions. Chapter 1 through 5 would be a great thing to look over and review after this course. So once again, there's a link to this inside of the GitHub repo. You could also just Google Eloquent JavaScript. I would definitely recommend it. And it's because it's a little bit of a deeper dive into this, it's great to jump into it after having watched these videos, because now you have the baseline, you can start to really dig into it. And then another resource we have here is this article called Understand JavaScript Closures with Ease. It does deal with some things like jQuery that we haven't seen, but it still could be a good resource for you. So check these out if you want a little bit more of an understanding of this. And as always, you're welcome to use the Slack channel, encouraged to use the Slack channel for questions. And finally, I would just say, if you really, really want to understand this, just keep using it. If you're going to take our full curriculum, that's a great way to get more exposure to all of this. These topics become really important in some of the frameworks we use, like Redux is extremely functional. That's a front-end framework, or a front-end piece that goes to React, which is a front-end framework. And if you're not planning on continuing with Lambda School, I would just say, keep practicing. You'll get it. It'll all start to make sense. So that is it for our lecture tonight. We do have an assignment as always. And I did want to say one thing about the assignment, which is that when you're working on these assignments, don't feel like you just need to be working in your text editor and then it's a total mystery until you run your tests on it. Replit is a great tool, not just for teaching, but for learning. When I'm writing code, especially if it's a piece of a bigger whole and I won't be able to see if it works until the end, when I was working as a software developer, I would have REPL it up and I would just run little pieces to make sure that they worked as I went. And you're totally welcome to do that while you're working on the homework. I would encourage you to do that. It'll give you a much better idea of what's going on. It shouldn't feel like you need to say Hail Marys when you're running things at the end. You should be able to test out and tweak the pieces as you go. And tools like this are great for that. So, little thing I wanted to say beyond that, everything as usual, homework's on GitHub. We're available in Slack for you guys. And that sums up everything for our lesson tonight on closures and scope. Do you guys have any questions for me? Go ahead and post those in the Slack channel. All right, bear with me. We've got a question being typed. Oh, great question. So it says, so Amy asked about the homework. It says to use closures to create a cache. What exactly is a cache? So a cache is essentially a value that's stored out of sight so that we can use it later on. So it's what we've been doing tonight, essentially. I just haven't used that word. So for example, this reverse string, this value that essentially goes away, but it's still accessible through this get Ryan Moss function. We would say that we cached this value. So another example might be a password. Let me just wipe the slate clean to show you this. So for example, if we wanted to have get login. So we want a function called get login info. And we want this thing to return an object that has a username and a password. And so we could use currying to cache the password. So essentially, we would, let me comment this out. So we could do something like this. We could have a function called password cacher. It takes in a password. And then it returns a function called, just an anonymous function that takes in a username. And then we return an object. So what I could do is now run password cacher and plug in my password, which is ABC123. Really secure password. I would recommend you all change your passwords to this. So, and this will, of course, give us a function. So call that get login. So now get login has cached this password out of sight, but we can still use it. So if I do get login and type in my username, somewhere my syntax is wrong. On line 9. What have I done? Can't believe you guys made me actually answer a question and have to think at the end of the night. Well, let's try it this way. And see. Oh, I forgot a return statement here. No wonder. Oh, I'll do it this way. Yes, thank you. So make sure that you are returning your anonymous function or else you will get an error, just like me. Okay, let's try it now. Yay, it works. Okay, so this could be useful, for example, if this logic were going on somewhere out of sight, whereas this logic were on the user interface. So, get login is available to your user, but this password cacher is kind of happening behind the scenes. So now I can run this and I have access to this awesome password, but I don't ever, it's kind of out of sight. This password variable has been hidden away using a closure. So it's, so we don't actually have to plug it in to get login, but it's available to us. So hopefully that answered your question, Amy. I don't want to give away too much because I want to make sure you guys get it. But if anyone wasn't familiar with the use of the word cache in the context of programming, or if there was some lack of clarity about how that relates to closure, hopefully this shed some light. Does anyone else have any questions before we wrap up? All right, time for you guys to go out there and write some of this code on your own. And as a little challenge for tonight, if you've never used Repl.it on your homework, I would challenge you to at least run one thing that you write tonight through Repl.it as you're going on the homework, just to see if maybe you like having a little bit of immediate feedback as you go. My guess is that you will be like, oh, this is awesome. Why haven't I been doing this from the start? All right. Thank you guys all for listening. We have 2 more lessons left this week. I hope you guys are feeling like you are total JavaScript wizards at this point. And if not, we are available to answer questions in Slack. Have a great night, everyone.